What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you what supervised learning, unsupervised learning, and reinforcement learning is as it relates to artificial intelligence. So let's get into it. Let's say you're trying to teach your dog a new trick, like how to fetch your slippers. You show her what to do, give her a treat when she does it right, and maybe offer a bit of encouragement when she doesn't quite nail it. That's called training. Now, what if I told you that teaching AI works a lot like training your dog? In the world of AI, we train machines using different types of learning methods. And the three big ones that you need to know are supervised learning, unsupervised learning, and reinforcement learning. And each one plays a unique role in how machines learn, adapt, and make decisions. And trust me, they're not as complicated as they sound. So let's go ahead and break all this down in plain English so that you have a thorough understanding of how all of this stuff works. First things first, why do we need learning models in AI? Now, before we dive into the differences, let's get one thing straight. Machine learning, which is a core part of AI, this is all about letting computers learn from data. So think of it this way. Instead of writing a specific set of rules for everything a computer should do, we let it learn patterns from data, just like we humans learn from experience. But how do we present that data to a machine? That's where these three learning methods come into play. All right, so let's start with the one that you're going to hear the most about, and this is called supervised learning. So exactly what is it? Well, supervised learning, this is like going to school with a teacher guiding you every step of the way. You get the questions and the answers, and your job is to learn the pattern. In technical terms, you feed the algorithm a data set that includes input-output pairs. The machine learns the relationship between them so that when it sees new input, it can predict the correct output. And here's an analogy to help you comprehend this. So let's say you're studying for a vocabulary test. On one side of the flashcard, it says feline. On the other side, it says cat. Now, over time, you learn that feline means cat. That's basically supervised learning in action. You're given the input, which is feline, and the correct output, which is cat, and you learn from that pairing. Now, here are some examples of supervised learning in action. The first one is email spam detection. So basically, you train a model on a labeled data set where the emails mark either spam or not spam. It learns the patterns and then it starts flagging future spam messages. Another example is loan default prediction. So you can feed a model a data set of customers, income, credit score, and a whole bunch of other stuff and label whether they repaid or defaulted. And then eventually the system's going to learn who's likely to repay. And then there's image classification. So you can show an AI thousands of images of dogs, cats, and birds, each labeled correctly. And then the AI will learn to classify new images based on what it has seen. Now, to make all of this happen, here are some common algorithms that are used in supervised learning. First is you have linear regression, you have what is called logistic regression, decision trees, support vector machines, and then you have neural networks that are used for labeled data. And the strengths of supervised learning is that it provides clear guidance with labeled data. There's high accuracy if this thing is trained well, and it's also easy to measure its performance. Its weaknesses, it requires a lot of labeled data, which can be expensive and time consuming, and it cannot handle unknown categories very well. All right, so let's talk about unsupervised learning. And this is the adventurous cousin of supervised learning. So exactly what is it? Well, unsupervised learning is like being dropped into a new city with no map, no guide, and no idea where you're at. Your job is to explore and find patterns on your own. In AI terms, this means you give the machine a data set with no labels. The algorithm explores the data and tries to group or organize it based on similarities. And here's a real world analogy to help you comprehend this. So imagine that you inherit a giant box of clothing. There are no labels, no categories. You don't know what belongs where. So what do? Well, you might sort the clothing by color, by type, and by season. And basically, that's unsupervised learning in a nutshell. You're finding structure and patterns without being told what's right. And here are some examples of unsupervised learning. So you have customer segmentation. And this could be where businesses that use unsupervised learning to group customers by behavior, buying patterns, or demographics without predefined labels. There's what's called market basket analysis. And this is where retailers use it to find product combinations that are often bought together, like somebody going to buy some chips and soda. And then there's anomaly detection. And this is used to find unusual data points like fraudulent transactions in banking. And here are some common algorithms that are used in unsupervised learning. You have what is called k-means clustering, hierarchical clustering, principal component analysis, and autoencoders. And the strengths of unsupervised learning are as follows. So there is no need for labeled data. It's great for discovery and exploration, and is helpful in summarizing or simplifying complex data. However, its weaknesses are it's harder to evaluate performance because there are no correct labels, and the results can be less predictable and interpretable. All right, so last but definitely not least, we got to talk about reinforcement learning. And this is the most dynamic and fun of the bunch. So, exactly what is it? Well, reinforcement learning, this is like teaching a dog tricks using treats and timeouts. So, when the dog sits, you give it a reward. When it jumps on the couch, you scold it. And over time, the dog learns which actions lead to good outcomes. Now, in AI terms, an AI agent learns by interacting with an environment. It takes action, gets feedback, which is a reward or a penalty, and improves its strategy over time. And a real world analogy to help drive this home is imagine that you're playing Super Mario Brothers. Every time you beat a level, you get points or a reward. If you fall into a pit and you lose your life, you get penalized. And then eventually you learn which moves work and which ones don't, and eventually you get better. That's essentially reinforcement learning. And here are some examples of reinforcement learning. So we have self-driving cars, where they're learning how to navigate roads by trying actions and getting feedback. It's also used in robotics, where you can teach a robot to walk, grab objects, or complete complex tasks. It's used in game playing AIs. So you have DeepMind's AlphaGo and OpenAI's 5. They use reinforcement learning to master Go and Dota 2, beating world champions. And then you have dynamic pricing models, where some businesses, they use reinforcement learning to adjust prices in real time based on demand and competition. And when it comes to reinforcement learning, here are the key concepts. So the first one is called an agent. That is the decision maker, or basically the AI. Then there's the environment, and this is the world the agent interacts with. There's the action. This is what the agent chooses to do. There's the reward. This is the feedback based on the action. There's the policy. This is the agent's strategy. And then there's what's called the episode. And this is a sequence of actions and rewards. And here are some common algorithms that are used with reinforcement learning. You have Q learning, deep Q networks, policy gradient methods, and actor critic models. The strengths of reinforcement learning are as follows. So it is great for learning sequences of decisions. It excels in dynamic environments, and it learns optimal strategies through experience. Its weaknesses are it can take a long time to train. It requires a lot of interactions with the environment, and it can be unstable or sensitive to reward design. Now, here's a chart that I put together to kind of sum things up side by side when it comes to supervised learning versus unsupervised learning versus reinforcement learning. So take a screenshot and get that in your life if this will help you understand this stuff much better. Now, just in case you're still not sure which one is which, let me go ahead and break this down again. When it comes to supervised learning, you can think of it like a bank that wants to predict if a customer will repay a loan based on income, credit score, and age. When it comes to unsupervised learning, you can think of it like a retailer who wants to group customers by purchasing behavior without knowing anything about them. And when it comes to reinforcement learning, you can think of it as a robot that's learning to walk by falling, getting back up, and being rewarded when it takes successful steps. Now, when it comes to all of these methods, can these learning types work together? Well, the answer is absolutely. In fact, many real-world AI systems, they combine techniques. The first one is called semi-supervised learning, and this uses a mix of labeled and unlabeled data. Then you have self-supervised learning, and this is a hot trend where AI creates its own labels from raw data, and this is used in models like GPT. And then you have reinforcement plus deep learning. This is also known as deep reinforcement learning, and this combination powers many cutting-edge systems like AlphaGo. So while these categories are helpful for understanding, the lines are starting to blur as AI evolves. So now that leads us to this next question. Why does any of this even matter? So if you're stepping into the world of AI, this knowledge isn't just nice to have, it's foundational. This knowledge helps you build smarter AI systems, It helps you choose the right tools for the job. It helps explain AI to non-technical people, and it helps you understand the strengths, limitations, and risks of each method. So whether you're training a chatbot, analyzing market trends, or building the next killer AI application, knowing how these machines learn, this can give you a serious competitive edge. Now let's go ahead and wrap all this up. So here's the big picture. Supervised learning. This is like solving a puzzle with the picture on the box. Unsupervised learning is like solving a mystery without knowing what you're looking for. And reinforcement learning, this is like leveling up in a game through one win or one failure at a time. Now, each method has its strengths, each fits a different kind of problem, and together they make up the toolkit that's powering everything from your phone's voice assistant to the future of autonomous robots. And the more you understand these learning styles, the more you'll see their fingerprints all over the tech world. And who knows, maybe the next breakthrough in AI will come from you. Now, with all of that being said, let's do some check on learning. So our first question is, which of the following best describes supervised learning? Is it the model learns from data that contains no labels or outcomes? Is it the model learns by receiving rewards or penalties for actions? Is it the model is pre-programmed with fixed rules and does not adapt? Or is it the model learns from labeled data to make predictions or classifications? And the correct answer is the model learns from labeled data to make predictions or classifications. So in supervised learning, the model is trained using a data set that includes both input features and corresponding correct outputs known as labels. It learns to map inputs to outputs, which make it suitable for tasks like classification when it comes to spam detection and regression when it comes to predicting housing prices. Next question, what is a key characteristic of unsupervised learning? Is it requires large amounts of labeled data? It uses feedback to learn optimal behavior over time. It discovers hidden patterns or structures in unlabeled data, or it relies on predefined categories for sorting data. And the correct answer is it discovers hidden patterns or structures in unlabeled data. So unsupervised learning does not rely on labeled outputs. Instead, it explores the data to find natural groupings or structures, like clustering customers based on purchasing behavior or reducing dimensionality using principal component analysis. And our final question, in reinforcement learning, what guides the learning process? Is it feedback in the form of rewards or penalties based on actions taken? Is it labeled data sets? Is it hidden patterns in data? Or is it pre-assigned categories? And the correct answer is it is feedback in the form of rewards or penalties based on actions taken. So reinforcement learning is all about learning through interaction. An agent learns to make decisions by performing actions in an environment and receiving feedback in the form of rewards or penalties, refining its strategy over time to maximize cumulative reward.